Okay, today's lesson is going to be transformation of functions. All of this should be a review from Algebra 2. I have two different ways I'm going to show this. I have a foldable and then I have some notes. So here's my foldable on the inside. If I look at what the outside is, I have my horizontal and my vertical. I just want to make sure that I understand that these are mirrored. So the X, how come it's not letting me? There we go. So the X is really this side of the inside of the foldable, and the Y is this side of the inside of the foldable. In the horizontal, the X transformations are backwards, so I actually like to color code my notes red. And the Y, the vertical transformations, I call normal, and I make those green, and that helps me understand a little bit more what's going on. Okay, so to go back to geometry, geometry had rigid and non-rigid transformations. So a rigid transformation, hang on, why is this not working? There we go. So a rigid transformation, the basic shape of the graph is unchanged and changes only the position of the graph. So the types of rigid transformations are horizontal shifts, vertical shifts, and reflections. So a non-rigid transformation is a stretch or a compress. And a non-rigid transformation changes the size and shape of the graph and causes a distortion. Okay, so let's talk about, so a horizontal shift is my C transformation. So if I say X minus C, I am moving to the right. So this is where I say if I'm subtracting, I'm backwards. But I actually move to the right. If I'm adding, I move to the left C units. So this is why I say they're backwards. So if I have a reflection, I have a y-axis reflection, so the x-coordinate, the sign changes. So 0 doesn't have a sign, so it stays as is. 1 becomes -1, and -4 becomes, 4 becomes -4, and nothing happens to y. So 0, 1, and 2. So if I plot this, it becomes a y-axis reflection and looks like this. So if I fold on the y-axis, I'm mirrored. Okay, so for my B transformation, this is my horizontal compress. It's a compress when the B value, the absolute value of it, is greater than 1. And what that looks like on a graph is it gets wider, but the correct word, or the more advanced word, is compress. And I'm interested in what's going on in relationship with the graph to the x-axis. So when I make it wider, I am going towards the x-axis. When B is, the absolute value is between 0 and 1, then I would move in, and I would say that's narrower. And again, I'm interested in what's going on with the x-axis, and I'm actually moving away. If I was in class, I would have someone and I'd ask you to look at your elbows and what's going on with your elbows. Am I pulling your arms up and your elbows going away from the floor, or am I pushing your arms down and your elbows getting closer to the floor? And this is going to be important when we get to trig functions, because everything is related to the x-axis. Okay, so those are the horizontal transformations. Let's talk about the vertical transformations. So the vertical transformations are what I call normal. So the D transformation is my vertical shift up. So if I'm adding, I'm going up. So I would call that normal. If I'm subtracting, I'm going down. I would call that normal. If I have a negative sign and it's outside the parentheses, this is where the sign of the y coordinate changes. So nothing happens to x, so x stays the same, but the sign of the y value changes. So 1 becomes -1 and 2 becomes -2. So if I did the reflection and plotted those new points, it would be a reflection over the x-axis. Okay, so for the vertical stretch and compress, so if A is between 0 and 1, the absolute value of it, I would call that a compress. And a compress means I'm getting wider. So what is going on with relationship to the x-axis means I'm going towards it. So when my A transformation value, absolute value, is greater than 1, I would call this a stretch. So this would be where I'm saying I'm pulling on your arms and your elbows are going away from the x-axis. So we would say narrower. And I see I didn't write one of the horizontal transformations. So over here, when I said it was narrower, this is a stretch. Okay, so this is my foldable version of the 4 transformations. So let's go through an example now with some notes. So my general form here is my y equals a times f of b times the quantity x minus c plus d. So again, I kind of give myself some clues. So my vertical transformations are A and D, and I kind of like make goalposts on the sides, and I'm doing them in green, and that gives me some visual clues that these are normal, and my B and C transformations are my horizontal, and they're backwards. So I like using color to give me a reminder that the horizontal transformations are backwards. Okay, so we have a couple things going on here, and I want to solve my transformations not from left to right. I actually am going to solve in a very specific order. So here, solve from the inside to the outside. Okay, so I'm going to start with if I am reflecting around the y or reflecting about the y-axis. So this is if b is negative. So I'm starting on the inside here if b is negative. If b is negative, then I am going to change the sign. So this is a sign change. So I'm not going to do, let me change it to blue here. What's going on? Well, here we go. So I'm going to change the sign. Well, okay, so I'm going to change the sign. When I change the sign, so then I'm going to move from, next I am going to look at C. And if C, this one is backwards. So when C is backwards, so it says X plus C, so that I'm not adding, I'm actually going to subtract the C from the X coordinate. And if I have X minus c, I'm doing the reverse, so that's add. So I'm going to add c to the x coordinate. So horizontal are backwards. So if I have a stretch or a compress, if b is greater than or equal to 0, then I am going to divide, so it's backwards, each x value by the b value. So let's now talk about the vertical transformations. So the vertical transformations, these are normal. So I like to make those in green. All right, so when I am reflecting, first I'm checking if A is negative. If it's negative, then I am going to change the sign. So I'm going to just change the sign of the y coordinate. So after I check for is A negative or not, and if A is greater than 0, I'm going to multiply each y value by A. And for vertical shifts, if I'm plus D, I'm going to add D to the y coordinate. And if I'm minus D, I'm going to subtract. So I really think of the goalposts, and the A and D transformations are normal, and B and C are backwards. And I'm solving from the inside to the outside. Okay, so let's do some examples here. So I want you to take a minute here and match 1 through 12. So I want you to pause the video and match. I want you to write the letter under the number. So pause the video. So if you, for instance, if you're going to be doing this and pausing your video. So the first one, this would be B. So pause your video, take a minute, and then come back and check. Okay, so 2 is E, 3 is H, 4 is D, 5 is I, 6 is A, 7 is L, 8 is C, 9 is F, 10 is J, 11 is G, and 12 is K. Okay, so let's graph one. So to graph this, we're going to do one transformation at a time. I'm going to start with the parent function. So here's my equation. And I'm going to start by drawing my parent function in. So my parent function, if I take out all the transformations, my parent function is y equals x squared. And describing that is my parent function. And my parent function is called a quadratic equation. So I'm going to graph my points for a quadratic equation. I know I have 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Okay. I need to know what are the basic points for each parent function. And we worked on parent functions last week. Okay, so the first thing I'm going to look at is that I don't have a negative for my B. So the first transformation I'm going to do is I'm looking at C. So I'm looking at C. So C is right here. So if I'm going to add that in, y equals x minus 2 quantity squared. This is my horizontal shift. And I'm going to shift right 2. So when I'm describing, I want to be as specific as possible. So I'm going to take each point and move each point right 2. And drawing in my new graph. I'm labeling each graph so it's really clear which transformation is on which one. Okay, next I am looking at, I see a negative sign with A. So the next thing I'm going to do is add the negative sign. So this will be y equals negative x minus 2 quantity squared. And this is an x-axis reflection. You just have to memorize these. So I'm going to take my current graph and I'm going to just reflect it over the x-axis. So I go to the same amount on the other side. So 1, 2, 3, 4. And 1, 2, 3, 4. Here we go. Okay, so my next transformation is A. So A is 4. So I have y equals negative 4 times the quantity x minus 2 squared. And A is my vertical stretch. And it's a stretch by a factor of 4. Okay, so I'm not only describing if it's a stretch or a compress, but how many times? So what I'm doing is I'm taking each y value and multiplying it times 4. So the y value here at 3, negative 1, so negative 1 times 4 is negative 4. The y value where the vertex is 0, so 4 times 0 is 0. And then at 1, negative 1, so the y value 1, negative 1 times 4 is also negative 4. So my stretch should make it narrower, which it did. So this is graph number 4. And then my final graph is D, my D transformation. I always do D last. So my D transformation is my vertical shift up. So this is y equals negative 4 times the quantity x minus 2 squared plus 3. So I'm going to take each point and go up 3. So this is a vertical shift up. And by 3. Okay. So vertical shift up 3. So I'm going to take each and go up 1, 2, 3, 1, 2, 3, and 1, 2, 3. So here we go. So here's my final. Okay, that's the end of the lesson.